Now see question number 4. Find nth derivative of the following. So see first sub question, x plus b raised to the power m. So we write here in solution y is equals to ax plus b raised to the power m. So differentiate this with respect to x first. So we get here differentiate with respect to x. After differentiating, we get derivative of y as dy by dx. Here we write power in multiplication. So write ax plus b raised to the power m minus 1. That means we apply here power rule first. Then we have to find derivative of this bracket. So write here derivative of bracket as derivative of first term. So derivative of ax is a, because a is constant, derivative of x is 1, so we write a into 1 as a, b is single constant, so its derivative is 0. So write here a into m into ax plus b raised to the power m minus 1. This is first order derivative. Now we again differentiate this with respect to x, then we get a second order derivative. So write a differentiate with respect to x. So derivative of dy by dx, we write d2y by dx2. So here a as it is. Here we write this power in multiplication. So m into m minus 1. Here its power again reduces by 1. So we write here ax plus b raised to the power m minus 1 minus 1, that is m minus 2. Then we have to find derivative of this ax plus b. So derivative of ax plus b, we get a. So we write here a into a square. So a square m as it is, m minus 1 into ax plus b raised to the power m minus 2. This is second order derivative. Now we again differentiate this with respect to x. Therefore write differentiate with respect to x. Now derivative of this d2y by dx2, we write d3y by dx3. Then a square as it is, this m into m minus 1 as it is. We write here derivative of this ax plus b raised to the power m minus 2. Here again we apply power rule. So write m minus 2 in multiplication and reduce the power of this ax plus b by 1. So we get here m minus 3 into again derivative of this ax plus b. So we write the derivative of ax plus b as a. So here we get d3y by dx3 as a cube into m minus 1, m minus 2, ax plus b raised to the power m minus 3. Now if you observe this third order derivative, from this we write the nth order derivative by replacing this 3 by n. So we write here in general, nth derivative is, now we have to write here nth derivative, that means we have to replace this 3 by n. So write here dn y by dxn is equals to, we replace this 3 by n, so we get here a raised to the power m, then m into m minus 1 into m minus 2 and so on. Next term, in place of here 2, we can write, if you observe this 2 means we get the value 1 less than the derivative order. That means here in place of 2 we have to write here value of m, we write here square bracket m minus, here if you observe value is 2 which is less than 1 by the derivative order, here order is n, so we have to write here m minus n, we take derivative of order n, so write here n minus 1 into, here we have to write ax plus b bracket raised to the power m minus 3, that means we have to write here m minus n. So if you multiply by minus sign, you can write this in this bracket in this way. So first write these terms m into m minus 1, m minus 2 and so on. Here we get m minus minus plus, so m plus n, sorry, here we get m minus n minus minus plus 1. So you can write this m minus n minus 1 as m minus n plus 1 and this ax plus b raised to the power m minus n as it is. Now if you observe, this power reduces m minus n. That means when you find the nth order derivative, the power of that ax plus b, we write m minus n, and here these values are in factorial form. So we write here the values in factorial form. This is n minus 1, the next value is n minus 2, the next value is n minus 3 and so on. So we get the value in reducing form. So we get value 3, then 2, then 1, that is we write in factorial form. So for that we write, if you observe this m minus n plus 1, then what will be the next value? M minus n. So we write here m minus n, multiply and divide by m minus n. Similarly we multiply and divide by m minus n minus 1. So write here a raised to the power m into m minus 1, m minus 2 and so on. Here m minus n minus 1. The next value will be, if we again subtract minus 1, we get here m minus n and so on. We get here 2 into 1. So here we have to multiply and divide by this term m minus n and so on. So we write in denominator m minus n and so on up to 2 into 1, and this ax plus b raised to the power m minus n as it is. So we write this as a raised to the power n. Now if you observe, this value is factorial of this m. So we write here m factorial upon, here we have to write m minus n factorial, and numerator we write ax plus b raised to the power m minus n. Now see, next sub question, we have to find nth derivative of this 1 by x. So write in solution, let y is equal to 1 by x. Now differentiate this with respect to x. So derivative of y with respect to x, we get dy by dx. Derivative of 1 by x is minus 1 upon x square. So this minus 1 upon x square, we write minus, if we write this x square in numerator, we write here x raised to the power minus 2. So this minus sign means we write minus 1. So write here minus 1 into x raised to the power minus 2. Now differentiate this again with respect to x. So write here differentiate with respect to x. So derivative of dy by dx, we write d2y by dx2 is equals to, now we keep minus 1 as it is. Then derivative of this x square, we write minus 2 into x raised to the power minus 3. Then again we differentiate with respect to x. So we get here d3y by dx3. Then we write here minus 1 into minus 2 into minus 3 into x raised to the power minus 4. So from this we write nth derivative. Then in general, nth order derivative is dny by dxn is equals to minus 1 into minus 2 into minus 3 and so on up to minus n. Then here we have to write power of x which is 1 less than this n, so write x raised to the power. Here if we observe, here is value 3, here value is -4, so you can write this x as so first we write here -1, -2, -3, x raised to the power -3 -1. So here also we write n as it is, so write here -n, then -1. So if you take minus sign common, we write here -1 into -2 into -3 and so on, -n into x raised to the power -n plus 1. So here -1, -1, -1 and so on up to minus. So we write here for this minus sign -1 raised to the power n, and this 1 into 2 into 3 and so on up to n in one bracket. So write here this x raised to the power -n plus 1 in denominator. So we write here x raised to the power plus n plus 1. So write here this -1 raised to the power n as it is, this 1 into 2 into 3 and so on up to n, we write this as n factorial. So we get here therefore dny by dxn is equals to this -1 raised to the power n into this, right, 1 into 2 into 3 into so on up to n, we write this as n factorial into 1 upon x raised to the power n plus 1 as the nth derivative of 1 by x. Now say next sub question, third, e raised to the power ax plus b. So first we write in solution given function as y. So write here let y is equal to e raised to the power ax plus b. Now differentiate with respect to x. So derivative of y we write dy by dx is equal to here e raised to the power ax plus b. So this is composite function. So first we treat as standard function. So write derivative of e raised to the power ax plus b as e raised to the power ax plus b into derivative of this ax plus b. So derivative of ax we write a, derivative of b we write 0. So we write dy by dx as a into e raised to the power ax plus b. Now we again differentiate this dy by dx with respect to x. So write differentiate with respect to x. So derivative of y we write d2y by dx2. Then here constant a as it is. Again derivative of e raised to the power ax plus b, which we already calculated. That is e raised to the power ax plus b into a. So we directly write derivative of this e raised to the power ax plus b as e raised to the power ax plus b into a. So we get here a into a as a square. So write a square into e raised to the power ax plus b. Again we differentiate this with respect to x. So differentiate with respect to x. Then we get third order derivative. So write d3y by dx3 is equals to. So here we keep a square as it is, and derivative of this e raised to the power ax plus b we write e raised to the power ax plus b into a. So write this as a cube into e raised to the power ax plus b. Now from this we write nth order derivative. So write here in general nth order derivative is, so we write here dny by dxn is equals to, here if order is 3 we get a raised to the power 3, if order is n we get a raised to the power n into e raised to the power ax plus b as it is. So in this way we find nth order derivative for function y equals to e raised to the power ax plus b. Now say sub question 4, a raised to the power px plus q. So we write here in solution let y is equal to a raised to the power px plus q. Now you can write here, differentiate this y with respect to x successively, because we write here differentiate with respect to x for first order derivative, then we write differentiate with respect to x for second order derivative. So you can write in one sentence, differentiate y successively with respect to x. So write here derivative of y with respect to x as dy by dx. So derivative of a raised to the power x is a raised to the power x. So instead of x, here value is px plus q. So this is composite function. So first treat as standard function. So write a derivative of a raised to the power px plus q as a raised to the power px plus q into log a into derivative of px plus q. So we write this as log a into a raised to the power px plus q into derivative of this px plus q is, derivative of px is p, derivative of q is 0, so we write into p. So write this as p into log a into a raised to the power px plus q. This is first order derivative. Now we again differentiate this derivative with respect to x. So we get here d2y by dx2 is equals to, now p log a is constant, so keep p log a as it is. Find a derivative of a raised to the power px plus q, which we get p log a into a raised to the power px plus q. So right here p log a into a raised to the power px plus q. So if we multiply p into p, we get p square. Log a into log a, we get log a, its bracket square, and here a raised to the power px plus q as it is. Now again we differentiate this with respect to x, we get d3y by dx3. We keep p square log a bracket square as it is, so write p square log a bracket square as it is, and derivative of this a raised to the power px, we get p into log a into a raised to the power px plus q. So we write p square into p cube, log a bracket square into log a, we write log a bracket cube into a raised to the power px plus q. So from this we write nth order derivative. Therefore in general nth order derivative is dny by dxn is equals to, here if order is 3, we get p raised to the power 3 log a raised to the power 3. So we write here p raised to the power n log a raised to the power n into a raised to the power px plus q. So in this way we find nth order derivative.